Hi everyone, welcome back to the channel. I'm Hussein Younes, an AI engineer, and in today's video we're going to be continuing our series on building AI agents from scratch. In today's video we're going to be going into deep dive on concepts in LangGraph. In the previous video we have talked about concepts of graphs and states in LangGraph, and we have built a little bit deep understanding of those concepts. In today's video we're going to be talking about nodes and edges. And yeah, hopefully after this video, we're gonna have like a much better understanding of how LangGraph actually works. As a result, you're gonna be building much better quality agents, and you're gonna understand how they work, and they're gonna be more useful. So yeah, what are nodes in LangGraph? So nodes are just Python functions that take this current state as an input. They also optionally can take the configuration or the context as an input as well. So every LLM or every agent needs context. So the context could be like the user ID, some like the API key, or some other things that we need to add to the context that doesn't change or like doesn't need to be included in the state itself. So here we can define the context. In this case, the user ID and the API key are added to the context. So this is a good example. And now we have our state. So our state consists of like very simple value, which is an integer, just a number. And here let's define our nodes. So like, let's see what are the ways to define nodes in LangGraph. So the first one, the basic node, it just gets a state, the current state as an input, and returns the state as an output, or the updated state as an output. So here it returns the value just incremented by 1. Now node with configuration, here we can pass the configuration as well to the node. So the configuration, for example, it contains the thread ID, which is the conversation ID that the agent is currently handling, right? The third way is where we pass the context. We pass it within LangGraph runtime. So the context carries variables that also we don't want to put in the state, like the user ID or the user profiles. Some variables that we can add to the agent without complicating our state. Let's also talk about some special nodes in LangGraph. So this is the start and end node. So the start node is just a virtual node that represents the entry point to the graph. The same way, the end is also like a virtual node that represents the termination of the graph. So it's the last node of the graph. So just keep that in mind. So in this case, in a very simple graph, the basic node executes, and the basic node just increments the input value by 1. So the output value is 6. Now let's talk a little bit about asynchronous node. So Python gives you a way to run your functions in an asynchronous manner, meaning that you don't need to block the CPU resources while waiting for input and output operations, like for example, reading or writing to a database. In the meantime, you can just free up resources for other processes or threads to run. You can do that by defining asynchronous functions in Python. You can read more about that. But in LangGraph, you can also invoke graphs in an asynchronous manner by asynchronous invoke, and we just await the results from the graph. So here, the node is asynchronous, and basically he just sleeps for 100 milliseconds. And here we just run the graph in a synchronous manner, and we just wait for the result. So the result in this case is 15 because we multiply the input by 3. It's very useful when you have multiple requests concurrently to your agent or to your application. In that case, you'd actually need to implement asynchronous execution. So now let's go to edges. So edges, basically, they just connect nodes, right? And this is how the state flows in the graph. And this is how we actually just like connect the nodes together. So there are normal edges just from node A to node B. There are conditional edges that we talked about in depth in a conditional routing video. So let's take this very simple example for edges. So we have node 1, step 1, step 2, and we're printing the step every time, and our state is a string, and we're appending the step number to the string, to the state. So here we have a very simple graph: start node, step 1, step 2, and then end node. And the initial value of the state is start, and we're gonna be appending to it. So we're gonna like put the state value, and then we're gonna add the step number to it. Now we execute the graph, and as we can see, it executes sequentially because the edges, they lead to nodes in a sequential manner. Yeah, so now I'm gonna talk about a new way of routing in LangGraph, which is the command. The command in LangGraph helps us update the state and route in a single node. Before, like in the previous video for conditional routing, we had to do this in 2 steps. First, we have a node that basically decides where we're gonna go next, and there is a separate function that we pass to the conditional edge. So we needed actually to add conditional edge, and then we needed to pass the function that's gonna read the state and that's gonna tell us where to go next. Now there is a way to do it without the need to add conditional edges, and we're gonna see how. So let's say the state is counter and should continue. The counter is just a number that we're going to be incrementing, and the should continue just a Boolean value, true or false, that's going to tell us whether we should continue the execution or we should stop. So here is our node, like the main node, increment and route. And this node can either, it returns a command that either goes to the same node, right? Like it routes to self, or it goes to finish. And we have another node finish. The graph looks like this. Either we have two nodes, start, increment and route, and finish. And the increment and route node either will go to the finish, or it's going to route to self. And you note here the dashed lines means that we have conditional edge. So it's either here or here. Yeah, so let's see how it works. So first we increment the counter. So we add 1 to the current counter from the state. Then we print the counter. And then if the counter is less than 3, we now return a command. So what the command does, it does two things. First, it updates the state. So we pass the updates to the state. So the counter, the new value of the counter is going to be new counter, which is counter plus 1. And we're going to go to increment and route. So we're going to just route to self. We're going to route to the same node like this. And if the else, so if the counter exceeds 2, so it's 3 or more, we're going to update the state with a new counter, and the should continue now should be false because we shouldn't continue anymore. That's how we want to define it. And then we go to finish. So the command is going to route the execution to the finish node, and the finish node is going to just print finish and return the state. So yeah, so let's see it in action. So first counter is 1, then 2, then 3. So it's rerouting to the same node. But now when the counter value is 3, we're going to go here and we're going to go to finish. And when we go to finish, we're going to see the word finished is printed here. You can take a look at this example. I'm going to upload it to GitHub, by the way. And now the final state, the counter is 3 and the should continue is false. So this is a very cool way to do the routing without conditional edges. So as you see here, we didn't do add conditional edges. We didn't do that. By just defining the commands, implicitly the LangGraph added those edges for us. So now this is putting it all together. This is just an example of routing of conditional edges. We had the same example in our routing video, so I'm not gonna go that in depth in that, but you can just check it out. Yeah, and that's actually it. So these are the main concepts actually that you need in LangGraph that you can build very interesting agents with, and we're gonna do that like in the near future. We're gonna be building very interesting agents using that. LangGraph is one of the most flexible frameworks for building AI agents. So you can build literally anything using LangGraph and LLMs. In the previous video, actually, if you have watched it, we had an error. So let me just explain the case really quickly. So look at this graph. Here we don't have conditional edges. LangGraph will execute first the start node, then it's going to execute both nodes in parallel. So now we had actually, the state was very simple integer value, right? And then we defined this graph the same way in the image here. And then we have actually just ran the graph. So when we ran the graph with the value 5, we got an error. What was the error? The error was at key value can receive only one value per step. This node was trying to update the value. It was trying actually to double the value. And the other node, node C, the parallel 2, was trying to add 10 to the value. Then LangGraph actually got confused. Like, oh, should I add 10 or should I like multiply by 2? By default, it got confused. To solve that, we actually can add a reducer that we learned in the previous episode. So the way we add that is just we add annotated, and we give it a function that is gonna be the reducer function, which is gonna tell LangGraph how to, if you have like two values, it's gonna tell you how to aggregate them or how to accumulate them. So in this case, we're gonna use add to aggregate the values, and let's see how that works in action. Okay, so let's solve this graph in LangGraph. Here we have 3 nodes: start node, parallel 1, parallel 2. Start node adds 1 to the value, parallel 1 multiplies the value by 2, and parallel 2 adds 10 to the value. Here we have a reducer function in LangGraph, add. So the reducer function, it takes the previous value of the state and it adds it to the new value. The input value, the initial value that we have is 5. So the start node will add 1 to the value. So 5 plus 1, new value is going to be 6. The reducer function takes the new value and adds it to the old value. Therefore, the new value is 11. Now, 11 is going to be passed to parallel 1 and parallel 2. And parallel 1 and parallel 2 will run in the same super step. So parallel 1 will multiply the value by 2. Therefore, the new value will be 22. Parallel 2 will add 10 to the previous value. Therefore, it's going to be 21. So now the reducer function will take these two values from the same super step and is going to combine them using the reducer function. So 21 plus 22 is going to be 43. And 43 plus the previous value is going to be 54. So the final value after the end of the graph execution will be 54. This is how LangGraph works. So as we can see here we have the implementation of this graph and the final value is 54. Yeah, so thanks so much for watching till the end. If you actually want to learn how to build AI agents using LangGraph from scratch, then check out the playlist on my channel. Yeah, thank you so much for watching till the end and see you in the next one. Bye bye.